Yes, ma'am.
Yeah. Okay, I hope you could remember that we have started with the assignment problem, and this is our unit 2 portion which we have to complete by today itself, because later on 2 units will be remaining. Third unit, which is game theory, and fourth unit, which is network analysis, Pert and Sikkim method we are going to deal with. So today probably we'll be completing this assignment problem with all possible types of included in. And let me revise first of all what we did in last lecture quickly, and then we can go for the rest of types. So assignment problem can be noted actually in this way. A verbal problem will be given, and using that we have to draft this matrix. So in this matrix we are having different components. One, which is represented by this particular portion. Second, these are the jobs to be done. Next, this is your column, which are the workers or draftsmen or anybody who is completing that job. This is our some supply availability, like the transportation problem we dealt with, and everywhere for each of the row, that supply quantity must be 1, because job 1 we will be assigning to any one of the worker only, and this is our demand. Here also we will be having the demand as 1 only. So what I all need here, the jobs is equal to number of jobs. I must write number of jobs is equal to number of workers. So problem is all about assignment of jobs to different workers. But while assigning the jobs to different worker, we can assign only one job to one worker. So that's why number of jobs must be equal to number of workers. What happened if this is not equal to? This is called as the unbalanced assignment problem. If it is equal to, this is called as a balanced assignment problem. So if it is unbalanced, in that case, either I can add dummy row here, dummy column, or I can add dummy row over here. Exactly like transportation problem, right? And we can proceed further to solve our simplification for assignment problem. Simplification in the sense it is just the assignment of job to particular worker. Now while assigning any job to any worker, what we have to take into consideration is the cost included in. Now if you are focusing on the cost matrix, these are your cost. Means W1 worker will require to complete J1 job this much cost. W1 worker will demand this much cost to complete J2 job, and so on. And amongst this cost matrix, I have to choose cost in such a way that, and the allocation in such a way that each job will get assigned to at least an unique worker, as well as the entire cost matrix will give you the minimum cost of the assignment. And in similar level, these variables x11, x12 and x1n will have certain value, and that value is 1 or 0. Means अगर मैंने W1 वर्कर को JN जॉब असाइन किया, then x11 will have value 1 and the rest of variables will have value 0. So यहाँ पर हमारी जो वेरिएबल्स है, जिसको हम डिसीजन वेरिएबल्स भी बोल सकते हैं, that will carry only values 1 or 0. So this is our structure which we discussed in last session already, and few of the concepts we have tried to understand. Type 1 and type 2 I already explained you. Then we discussed different phases. Phase 1, which is dealing with the matrix reduction, which involves row as well as column reduction part, and phase 2 is the optimization of the problem. So this phase 1 and phase 2, whatever way we are carrying out, is called as the Hungarian method. Hungarian method, and this will lead to optimality. But I must mention that Hungarian method, though it leads to optimality may not give you the optimal solution in some of the cases, and that is because how you are going to break down your tie values, break down your tie values. Based on that, Hungarian method will decide whether it will going to give you optimal solution or not. So it's a question mark on Hungarian method. It will not give you in any random case optimal solution, or may not give optimal solution in that case. But maximum times all the possibilities we can address here. So however, problem will be given in the examination. You can always address Hungarian method to give one of the solution out of the possible. So how to find out that we have seen through one problem. Again I'll just repeat that. हम क्या क्या करते हैं. Phase 1, step 1, we subtract minimum value of each of the row from all the entries of that row. Step 2, we subtract the minimum value of each column from all the entries of that column. So first of all we are going row reduction, and then we are going to do the column reduction. So इन दोनों भी steps के बाद हमें मैट्रिक्स रिड्यूस फॉर्म में मिल रहा है, जहां पर हर एक रो में एंड हर एक कॉलम में एक जीरो तो डेफिनेटली होगा ही. आफ्टर दैट वी हैव टू डू द स्टेप 3 व्हिच इज कॉल्ड एज द रो स्कैनिंग और कॉलम स्कैनिंग. तो स्कैनिंग करेंगे मीन्स क्या करेंगे, हम हर एक रो में एटलीस्ट 1 जीरो है तो उसे मार्क करने वाले हैं. सो दैट इज कॉल्ड एज अवर एलोकेशन. एंड वो जो एलोकेशन है जैसे हमें मिलता है रो वाइज, हम उस कॉलम को डिस्कार्ड करेंगे, मीन्स डिलीट करेंगे या स्ट्रेट लाइन वहां पर निकाल के रेड मार्क कर देंगे. इन सिमिलर वे कॉलम स्कैनिंग यू हैव टू डू. जहां जहां पर आपको एक जीरो दिखेगा कॉलम में, दैट जीरो यू हैव टू एलोकेट एंड दैट रो यू हैव टू डिलीट और स्ट्राइक आउट. सो दैट सिंपल रो एज वेल एज कॉलम स्कैनिंग हमें कंप्लीट करनी है. कब तक, जब तक सारे के सारे जीरो एलोकेट नहीं हो जाते तब तक. करेक्ट. देन विल गो टू स्टेप 4. अगर आपके नंबर ऑफ स्क्वायर्स ऑफ जीरोस मार्क्ड, आई एम सॉरी, number of squares of zeros which are marked already through the row as well as column scanning is equal to the total number of rows or columns. In that case we are reaching to the optimality. अगर ऐसा नहीं होता है then go to step 5. What is that step 5? Identify the minimum value from the undeleted cell values and add minimum undeleted cell value at the intersection point to the present matrix. Second, subtract this minimum value from undeleted cell value from the all undeleted cell values. And last step we have to under step 5, all other entries will remain same. And again I have to start from step 3, that means row scanning, column scanning. तो मुझे सबसे पहले क्या चेक करना है कि हमारे जो नंबर ऑफ allocated zeros वो इक्वल टू होने चाहिए नंबर ऑफ रोज या नंबर ऑफ कॉलम्स के. एंड इफ दिस कंडीशन होल्ड्स then we are reaching to our optimality. Else we'll repeat step 5 and step 6 again and again until and unless we are getting the allocation. हम जीरो को allocate क्यों कर रहे हैं ये मैंने आपको बताया था. See this example. यहाँ पर मेरे पास ऑपरेटर 1 को एक जॉब असाइन करना है, वन ऑफ द 5. अब मैं किसको असाइन करूंगी, लिस्ट वैल्यू को. लेकिन अगर मैंने ये लिस्ट वैल्यू यहाँ पर चूज की, यहाँ पर ये लिस्ट वैल्यू चूज की, देन यहाँ पर यह की और यहाँ पर ये की, तो हो क्या रहा है, फर्स्ट ऑपरेटर को भी 5th वाला जॉब असाइन हो रहा है, 4th ऑपरेटर को भी 5th वाला जॉब असाइन हो रहा है. दैट शुड नॉट बी पॉसिबल. एक जॉब एक ही वर्कर को असाइन होना चाहिए. So this allocation is not possible. And to do it in a very stringent way, we are going to delete. We are going to subtract, not delete. We are going to subtract the minimum entry of row as well as column from the rest of other entries. So that zero allocation, we suggest that you are choosing minimum value of that particular row or column. and that's why this method is adopted to allocate at fine level if we are having giant number of workers and giant number of jobs as well. So यही प्रॉब्लम शायद हमने उस दिन कंप्लीट किया था. We'll go for one more problem. If that problem is clear to everyone, we can go for next type as well. So shall I take one more problem of this Hungarian method with basic type, or shall I go for next method?
You can go for the next one. Yes.
Okay. So these are few problems, you can go for that. Our next method is maximization case. This we have not discussed that day. Now every problem up till we discussed was the minimize cost for given assignment problem AB. So this question we have dealt with, but at the same time, as we are minimizing the cost, we are maximizing our profit, right? So such problem can come under this particular case of maximization. In that case, one additional step we have to do with in addition to that Hungarian method. So what that additional step is, if instead of cost matrix, profit matrix is given, then assignment are made in such a way that total profit can be maximized, and the profit maximization problem are solved by converting them into a cost minimization problem in either of the following way. Means maximization का case जो profit के maximization के लिए है, that we can minimize to that we can convert to the minimization problem. How to do that? Case 1, put a negative sign before each of the element of the profit matrix in order to convert profit values into the cost values, or subtract all the elements of the profit matrix from largest element including itself. So here onwards, this particular step we can adopt easily for the maximization problem. So let us try to solve one problem, and the rest of process will be similar. Now see the question. A marketing manager has 5 salesmen and 5 sales district. Considering the capability of the nature of the district, the marketing manager estimates that the sales per month in hundreds of rupees for each salesman in each district would be as follows. So this matrix you have been given. So these are the districts. So you can consider this as a job, and these are the salesmen. So हर एक salesman को एक district हमें allocate करना है, and the profit problem is of maximization. See the question. Find the assignment of salesman to the district that will result a maximum sale. So यहाँ पर जो sale की cost है ना, ये देके रखी है, that we have to maximize. Now इस मैट्रिक्स को हम मिनिमाइजेशन की मेथड से सॉल्व नहीं कर सकते. But all things we are going to do is we are going to check out the maximum value of this entire cost matrix. So now you can name the identify the maximum value of this matrix, and it's 41. Besides 41, no value is maximum. So what we are going to adopt the method over here, हम इस maximum value से rest of सारी entries को subtract कर देंगे. What will happen with that? Problem will convert to minimize. Can you explain how?
We will get the difference, and that we can then proceed further with solving the differences.
Correct. So what things you are going to do is this one. Sorry, a different problem. यहाँ पर आंसर है ही नहीं. We'll solve that on a journal page. So 41 से हम सब values subtract कर रहे हैं. So I'm going to get 0 at this position. इस पोजीशन पर मुझे 0 मिलेगा, राइट? एंड 0 को हम हंगेरियन मेथड के साथ अलोकेट कर रहे हैं, मींस चूज कर रहे हैं. सो अगर मुझे यहाँ पर 0 मिल गया, and by Hungarian method I am selecting this 0, means I am allocating this particular cell. That means I am choosing this salesman 3 for district A with the cost 41, and eventually that will maximize my sale. But we have to convert first of all this particular cost matrix and the second condition we have discussed earlier. So सबसे बड़ी वैल्यू जो है 41, उससे हमें सब वैल्यू सब्ट्रैक्ट करनी है. So let us try out this problem on journal. Let me open it. Okay. So let us draft first of all one matrix. Yes, so this is your problem 1. These are the districts A, B, C, D and E, and these are the salesmen S1, S2, S3, S4, S5. Alright. I'm so sorry. What happened? I don't know. A, B, C, D, E, and this is S1, S2, S3, S4, and this is S5. So first of all, I'll enter the cost matrix 32, 38, 40, 40, then 28, 40, okay, 40, 24,
40,
so
28,
40, 28 na?
28,
21,
21, 36.
yes, okay, next,
And 41,
27,
27,
30,
33,
30, yes,
30, 37.
yeah, S4,
And 32, 38,
41,
41,
Hmm.
36, 36.
okay, this is 35, 39 here I guess, and this is 29, 33, 40,
29, 33, 40.
yeah.
33, 40.
So what now we are going to do is we are going to subtract each entry from this 41. 41 is the highest value. So problem is of maximization, and by doing this we are going to convert the problem to the minimization part. ठीक है? So यहाँ से हम subtract करते हैं. So 41 minus 32. It's 9 here, right?
Only the values, not the sign.
Sorry. Shall I
Only the
write it?
values, not the.
Okay, मैं नीचे लिख देती हूँ, that will better. This is A, B, C, D, and this is E. S1, S2, S3, S4, and this is S5. Yeah. So 41 से हमें 32 subtract करना है. So this is 8 plus 1, 9 here. Then 41 minus 38, 3, 1, 41 and 18. So this is 1 and 3, I guess, correct? Yes. 1 here. Then this is 1 here. 24 हम subtract कर रहे हैं. So this is
17.
7, 17. S2, 28 से subtract कर रहे हैं. 6, 13, 21. So this 3 and this is 2, 23. यहाँ से हम 4 plus 1, 5. यहाँ पे 0. Then this is 27 है ना यहाँ पर. So this is 14, I guess. Then 41, 33. So this is 8. Correct?
And we don't
यहाँ
have
पर.
to put minus sign.
I'm sorry.
Minus sign we don't have to put. Like minus 9.
No,
No, not minus sign, because what you are doing, you are choosing the highest number over here and you are subtracting the rest of entries.
Okay.
Okay. So 11 over here. This is 3 plus 1 4. Next row. It's 9. 1 9. Then यहाँ पर बचेगा 4 once again. Sorry, 3. 3 here. 0 over here. Then this is 5. 5. 29 हम subtract कर रहे हैं. So it's 2 1 12. यहाँ पर 33 को subtract कर रहे हैं. 8 correct. यहाँ पर 1. This is 5 plus 6 and this is 2. So we have converted the matrix to minimization, right? अब यहाँ पर हमें मिनिमम वैल्यू चूज करनी है. So मिनिमम वैल्यू चूज करने के चांसेस क्या है? This one, all the ones and zeros. We will do with the standard method जो हमने row reduction and column reduction की मेथड सोची थी वहां से करते हैं. So I'll just write down that row and column reduced matrix here. ठीक है. Once again write down that matrix. This is A, B, C, D and E. यहाँ पर S1, S2, S3, S4 and this is S5. So हम अब क्या करेंगे? लीस्ट वैल्यू चूज करेंगे हर एक रो से, हर एक कॉलम से. Just write down that least value here. It's 1 1 here, 0 0 1. जहाँ पर 0 है उस रो में कुछ चेंज नहीं होगा, बट रेस्ट ऑफ रोज में हम चेंज कर सकते हैं. सो यहाँ पे हो जाएगा 8, राइट. दिस इज 2. यहाँ पे 0, यहाँ पर 1 सब्ट्रैक्ट करें 12, यहाँ पर 0, यहाँ पे 0 16 12 22, यहाँ पे 4. करेक्ट. यहाँ पर कुछ चेंज नहीं होगा. सो वैल्यूज आई कैन राइट डाउन इन सिमिलर वे. 8 11 एंड दिस इज 19 3 0 5. No change in this row. Then next row 1 है least value. So this is 11 7 0 5 and 1. So row reduction we have completed. Now we can go for the column reduction. Column reduction कहाँ पर हो सकता है? Only column B and D पर, because rest of columns have already values zeros as one of the entry. So that column will not change at all. So first column will remain as it is. This is 8 0 0 19 and this is 11. यहाँ पर 2 least value 2 है, so यहाँ पर बचेगा 0. This is 14 12, यहाँ पर 1 and this is 7 minus 2, it's 5 here. C column will remain as it is because 0 entry is already there. D column will change. Minimum entry is 5, so 5 को subtract कर देते हैं. यहाँ पर बचेगा 7. This is 5 we are subtracting, so it's 17 6. This is 0, यहाँ पे 0 and last column will remain same because 0 entry we are having already over there. Yes, we are now having complete row as well as column reduced matrix over here. Now what we have to do? We have to do the row as well as column scanning. कैसे करनी है? So first of all we'll go by row. Row wise हमें scanning करनी है and secondly we have to do column wise scan. Right? So let us start from row. Row 1 3 zeros है. अगर एक ही 0 है तो हमें allocate करना है, else not. ठीक है. सेकंड रो एक ही 0 है तो हम इसे allocate करेंगे एंड कॉलम को हम subtract करेंगे, डिस्कार्ड करेंगे. ठीक है. गो टू नेक्स्ट रो. अब यहाँ पर एक 0 था वो डिस्कार्ड हो चुका है, सो हमारे पास कोई भी 0 नहीं है. आई गो टू नेक्स्ट रो. अब यहाँ पर 2 zeros है, आई कैन नॉट allocate. अगर सिंगल 0 होता तो ही हमें allocate करना है. आई मूव टू नेक्स्ट रो. S5 यहाँ पर भी 2 zeros है, आई कैन नॉट allocate. Am I right? Now let us do the column scanning. Column 1 already discard हो चुका है, so I cannot write down the allocation. Column B यहाँ पर एक ही 0 की एंट्री है तो मैं allocate कर रही हूँ, but now in that case I have to discard the row. Go to the next column C. एक 0 था वो discard हो चुका है, rest of 2 zeros है, I cannot allocate. Go to the next column D. यहाँ पर 2 zeros है, I cannot allocate. करेक्ट. एंड E यहाँ पर भी कोई भी 0 नहीं है, सो आई कैन नॉट allocate. अगेन मुझे फिर से रो एज वेल एज कॉलम स्कैनिंग करनी होगी. कब तक? जब तक जीरो नहीं हो जाते. आर यू गेटिंग माई पॉइंट?
Can you repeat that one?
Yes. So I'll just repeat that once again.
From that,
Yes, yes, yes. So I guess till this step it's clear to everyone.
Yes. Before that, I think before this table, one table was there.
Table 1.
Yeah. No, about table.
Okay.
Yeah, this one.
Huh. So in this we row reduced it, right? And now we have to column reduce it after this step. So this column has already 0 as the least number. तो 0 को हर एक एंट्री से हमने सब्ट्रैक्ट किया तो यही मेंबर्स बचेंगे ना. सो नो.
Okay, तो पहले हमने वो रो किया, फिर बाद में कॉलम किया.
यस. बट कॉलम में हमारे पास यहाँ पर 0 है, इसलिए मैं फर्स्ट कॉलम को चेंज नहीं कर रही हूँ. कॉलम बी को मैं चेंज कर रही हूँ क्योंकि यहाँ पर 0 की एंट्री नहीं है. 2 इज द लीस्ट एंट्री और 2 मैंने अगर सब्ट्रैक्ट किया तो सारी एंट्रीज हमारी चेंज हो जाएगी. इज दैट क्लियर?
Yes, ma'am.
Okay. So we got this matrix, which is called the row and column reduced matrix. Now we have to do the allocation. So allocation हम हमेशा row wise and column wise करेंगे. So row wise will allocate first of all. This is 0 0 0. 3 times 0 we are having. We can allocate if and only if single 0 is there either in row or in column. So we cannot allocate for first row. Second row में हम एक ही 0 है इसे allocate कर सकते हैं. And once we are allocating S2 को सेल्समैन 2 को मैंने ए वाला डिस्ट्रिक्ट एलोकेट किया है. करेक्ट? व्हाट दैट मीन्स हम ये जो डिस्कार्ड कर रहे हैं व्हाट दैट मीन्स हम ये वाला ए डिस्ट्रिक्ट हम किसी और सेल्समैन को एलोकेट नहीं कर सकते. द एलोकेशन हैज बीन डन विद दिस 0 एलोकेशन, इसलिए हम स्ट्राइक आउट कर रहे हैं. गॉट माई पॉइंट एवरीवन? यहाँ पर किसी को डाउट है स्ट्राइक आउट के लिए?
Madam, here the district has been allocated or the salesman has been allocated?
हाँ, S2 is allocated to A. A is allocated to S2, whatever you say.
Then we can allocate S2 also for any other district and A also for any other salesman.
Correct, that's true. इसलिए हम पूरा कॉलम ही डिस्कार्ड कर रहे हैं. रो वाइज वी आर सेलेक्टिंग एंड कॉलम वाइज वी आर डिस्कार्डिंग. So my allocation S2 goes to A. That's fixed now with this allocation. Is it clear? Shall I move ahead?
Yes, ma'am.
Okay. Now come to the next row S3. S3 में सिंगल 0 था लेकिन डिस्कार्ड हो चुका है. I cannot select S3 against A क्योंकि A already S2 को allocate हो चुका है. Correct? So I have to move to next row S4. Now S4 is having 2 zeros. It's a tie. So right now I cannot select. Until and unless a single 0 entry is there, we cannot allocate. So we'll go to S5. Again I am having 2 zeros. I cannot allocate. So now I'll go for column scanning. So column 1 पर हम allocation कर ही नहीं सकते because it is discarded. I'll go to next column. B वाला कॉलम चलता है यहाँ पर. So I'm having single 0 at this position. I'm going to allocate it. लेकिन जैसे मैंने ये allocation किया है, what you can fix here, S1 is allocated to B. That means now the other entry is allocated against S1 and against B. So I'm discarding that row. Similar way, the rest of columns we can scan. So come to now this column. I am having 2 0 entries. I cannot allocate. Go to the next column. I am again having 0 entries in number 2. So I cannot allocate that. Come to E. We don't have any 0 left out. Correct? So again I can go column wise or row wise. हमने column wise complete किया, अब row wise चलते हैं. S1 already discarded. S3, S2 no 0, S3 no 0, S4, 2 zeros I cannot allocate, S5, 2 zeros I cannot allocate, and we now trapped into the loop. अगर मैं बार बार रो स्कैनिंग या कॉलम स्कैनिंग करूंगी यहाँ से आगे, then I am going to get a similar kind of structure जो यहाँ पर फंस रहा है, इस जगह पर फंस रहा है. Getting it? And this is the position of your tie. Am I right? I hope
Yes, sir.
this situation is clear to everyone.
Yes.
Okay. Now we can what we can do? Now we can randomly allocate the zeros. Randomly allocate zeros. Randomly allocate. Suppose मैंने ये चूज किया. What that means? मैं S4 को C के अगेंस्ट फिक्स कर रही हूँ. That means obviously I cannot allocate any other member of this column. Correct? That means again I cannot allocate this zero also. तो ये जीरो और ये जीरो में स्ट्राइक आउट कर देती हूँ क्योंकि उस रो में या उस कॉलम में मुझे फर्दर जीरो नहीं चाहिए. Am I right? So अगर मैंने ये भी सेलेक्ट कर लिया along with this one, what will happen? S4 is allocated to C, S4 is also allocated to D. That's not possible. मुझे एक सिंगल allocation करना है. So I can cancel out both of the entries of zeros here. In that case, if you are doing row scanning and column scanning, I will left out only this zero. Correct? अगर ये जीरो में allocate कर रही हूँ, so definitely रो वाइज अगर किया तो मैं कॉलम को स्ट्राइक आउट कर सकती हूँ एंड इसे भी स्ट्राइक आउट कर सकती हूँ. बट आफ्टर रैंडमली allocate the zeros, how many zeros I am going to get here? 1, this is 2, this is 3 and this is 4. क्योंकि after a choice of random allocation of the zeros, I am having the number of allocations of zeros as 4, but the number of rows or number of columns are 5. Means we have not yet reached to the optimality condition. Am I right? Once again, before we go for the optimality condition, I'll explain you once again कि ये जो zeros मैंने यहाँ पर allocate किए ना, I can change that. First, I allocated this 0 and this 0 and these two be discarded. It's my choice. Second possibility, what is there? Suppose instead of this 0, I have selected this 0. In that case, these two zeros are crossed and this is left out to allocate. तो अगर आप यहाँ पर ऑब्जर्व कर रहे हो, so diagonal zeros are only there to select. मैं इसे and इसे भी select नहीं कर सकती. I can just select the diagonal elements to fix our allocation of assignments. I hope I am clear. Right? So with any choice, now here you are having two choices. Choice 1, S4 is allocated to C, means I am choosing this, and S5 is allocated to D, I am choosing this. These two I can strike out. Am I right? And second choice you are having is this one. Choice 2, I am allocating S4 to D and S5 to C. Now, though the choice of zeros, allocation of zeros is random, I have to fix, to proceed further, I have to fix either choice 1 or choice 2. It will be totally depend on your choice of I values. Okay. Suppose if we choose this choice 1 where S4 is fixed with C, S5 is fixed with D. Now let us freshly note down this allocation as another matrix once again. This is A, B, C, D, E. Over here S1, S2, S3, S4, and I'll just repeat the values. 80070. Then 0, 14, 12, 17, 4. something is missing. 14, 12, 17, 17 and 4. Okay. 0, 12, 8, 6, 4. S4 is 19, 1, 0, 0, 5. And S5 is 1, 5, 0, 0, 1. Okay. Yes. Now let us allocate once again. So this is our allocation. This we are discarding. Then here we don't have allocation. यहाँ पर ये allocation है. We are discarding this one. And then we have our choice this one. So ये हम cancel कर सकते हैं. So मैं row wise अगर इसे select कर रही हूँ तो मैं column wise cancel कर देती हूँ इससे. ठीक है. And again I can do the scanning. अब यहाँ पर 0 बचा है तो मैं इसे select करती हूँ. That means once again I am striking out this one. Okay. Now I can write down the number of allocations. Less than or not equal to number of rows. Number of allocations of zeros. So number of allocations of zeros कितने हैं? 4. And number of rows कितनी है? 5. Obviously 4 is not equal to 5. Means we have not reached to optimality. So optimality not there. So we have to reach to the optimality now. So what we can further do? So जो step 5 हमने choose की थी ना, वो हमें discuss की थी, वो हमें यहाँ पर apply करनी है. What that step is? तो carefully check करो यहाँ पर. मुझे undeleted values में से, now what are the undeleted values? 14, 12, 1, 5, 4, 4, 5, 1. ये आपकी अनडिलीटेड वैल्यूज है. इसमें से सबसे लीस्ट वैल्यू आपको चूज करनी है. व्हाट इज इट? व्हाट इज दैट वैल्यू?
1.
इट्स 1. करेक्ट. तो ये 1 आपको सब अनडिलीटेड वैल्यूज में से सबट्रैक्ट करनी है. दिस इज वन स्टेप. फर्स्ट स्टेप द चॉइस ऑफ लीस्ट वैल्यू फ्रॉम अनडिलीटेड. सेकंड स्टेप इस वैल्यू को अनडिलीटेड सेल वैल्यू से सबट्रैक्ट करना है. एंड थर्ड स्टेप जहां जहां पर आपका इंटरसेक्शन है इन रेड लाइंस का, व्हिच आर दैट पोजीशंस? दिस इज दैट पोजीशन जहां पर इंटरसेक्शन है. ये एक पोजीशन है जहां पर इंटरसेक्शन है और ये एक पोजीशन है जहां पर इंटरसेक्शन है. इन तीनों पोजीशंस को छोड़ के कहीं पर भी लाइंस का इंटरसेक्शन नहीं है. तो इन तीनों भी पोजीशंस पर ये लिस्ट वैल्यू आपको ऐड करनी है. गॉट माय पॉइंट? तो सबट्रैक्ट कहां से करना है? अनडिलीटेड सेल वैल्यूज से. एंड ऐड कहां पर करना है? पॉइंट ऑफ इंटरसेक्शंस पर. सो मैं यहां पर ही करके दिखाती हूँ. सो हियर इट विल रिमेन 0. यहाँ पे क्या बचेगा? 11. हियर 13. ओवर हियर दिस इज 4. यहाँ पे 4. यहाँ पे 0, 3, 3. सो अनडिलीटेड सेल वैल्यूज में से हमने लिस्ट वैल्यू सबट्रैक्ट करके ये सिंप्लीफिकेशन किया. नाउ ओवर हियर इंस्टेड ऑफ 7, 8, यहाँ पर 0 की जगह 1 और यहाँ पर 9. Okay. Now what we have done over here, we have reallocated the undeleted cell values, ऐसा हम बोल सकते हैं. And once again I can go to steps 3 जहाँ पर हम row scanning and column scanning कर रहे हैं. Am I right? So let us do that once. So यहाँ पर मुझे फिर से ये मैट्रिक्स लिखना पड़ेगा. A, B, C, D and E. This is S1, S2, S3, S4 and this is S5. Over here I am getting 9. New value, right? 0, 1, 8, 0. Rest of values remain same. ये 0 as it is रहेगा. ठीक है? 0, 13, 12, 17, 3. 0, 13, 12, 17, 3. तो चेंज कहाँ कहाँ पर हो रहा है वो सिर्फ नोट डाउन करो. देन 0, 11, 6, 0, 11, 6, 8 and 3. Then 19, 0, 0, 0, 4. 19, 0, 0, 0, 4. And last 1, 4, 0, 0, 0. सही है ना, 1 4 0 0 0 1 4 0 0 0. So this is entirely a different matrix than above. Now once again let us try the row scanning and column scanning. So row scanning के लिए यहाँ पर 2 zeros है फर्स्ट रो में, I cannot allocate. सेकंड रो में यहाँ पर एक जीरो है तो हम ये allocate करते हैं, but now I have to strike out this column. Third row, no zeros left out. Fourth row, 3 zeros I cannot allocate. S5, 3 zeros I cannot allocate. Go column wise. First column is already striked out. B column, 2 zeros are there, I cannot allocate. C column, I cannot allocate, 2 zeros are there. D I cannot allocate. E हम allocate कर सकते हैं यहाँ पर. And मैं column wise allocation कर रही हूँ. That means S5 row I have to discard. ठीक है. So again I will go column wise and row wise. हमने E तक आए थे, column wise हम फिर से repeat करते हैं. So S1 2 zeros are there. S2 already हो चुका है. S3 no zeros. S4 3 zeros I cannot allocate. Go column wise. A already striked out. B 2 zeros are there. C एक जीरो यहाँ पर है. Am I right? And this row I can discard. D no zeros left out. E यहाँ पर एक जीरो है, but I cannot allocate this. Am I right? क्योंकि हम यहाँ पर already allocate कर चुके हैं, right? So we cannot allocate that. Again, if you are going column wise or row wise, I have to select this. So what is the only option left amongst these 2 zeros to choose? This is not possible. So only column wise this value is left out. So हम यहाँ पर ये discard करते हैं. Again if you are observing, यहाँ पर 1, यहाँ पर 2, 3 and 4 zeros का ही allocation हुआ है. तो once again what I have to try? Again I have to choose a least number amongst undeleted values. ये है 3, तो ये 3 हम सबसे subtract करते हैं, intersection के points पर हम ये add करते हैं. So यहाँ से 10, यहाँ पे बचेगा 9, this is 14, यहाँ पे 0, this is 0, यहाँ पे बचेगा 5, यहाँ पे बचेगा 3, here this is 7, 8, right? And यहाँ पर आएगा 3 plus 9 12 और इंटरसेक्शन की पोजीशन है यहाँ पर, so 19 की जगह आ जाएगा 22 ही होगा ना, 3 yes, and 1 की जगह पर आ जाएगा 4. Got it? तो फिर से मैं इन नए वैल्यूज के साथ एक बार फिर से मैट्रिक्स बना लूं. I'll just go for that. A, B, C, I'm sorry. A, B, C, D and E. यहाँ पर S1, S2, S3, S4 and this is S5. Let's write down all the values. यहाँ पर 4 0 0 0, यहाँ पर होगा 22, दिस इज 0, यहाँ पर होगा 0. मैंने यहाँ पर 3 क्यों लिखा है? सॉरी, ये इंटरसेक्शन का पार्ट नहीं है. 0 0, दिस इज 4, यहाँ पर 0 11 की जगह 8, यहाँ पर 3, दिस इज 5, दिस इज 0, यहाँ पर हो जाएगा 1. ओके, ये हमने लिखा था. ओके, दिस इज 0 10, यहाँ पे 9 14 एंड दिस इज 0, दिस इज ओवर हियर 12 0 1 8, यहाँ पे 0. ठीक है. फिर से रो एज वेल एज कॉलम स्कैन. फर्स्ट रो नॉट पॉसिबल, सेकंड रो अगेन नॉट पॉसिबल, थर्ड रो नॉट पॉसिबल, फोर्थ नॉट पॉसिबल, फिफ्थ नॉट पॉसिबल. फर्स्ट कॉलम नॉट पॉसिबल, सेकंड कॉलम नॉट पॉसिबल, 2 zeros आर देयर. सी भी पॉसिबल नहीं है, डी भी, ई भी. तो यहाँ पर हमारे पास सब तरफ रैंडम चॉइस है. ओके, सो मल्टीपल पॉसिबिलिटीज आर देयर. सो अगर मैं यहाँ पर फर्स्ट रो वाइज में चॉइस करती जाती हूँ, मेरे पास चॉइस क्या है? S1 के लिए B एज वेल एज E. यू कैन फिक्स एनीवन. गेटिंग माय पॉइंट? आप बी कर सकते हो, ई कर सकते हो. So again you can look into your original matrix over here. ओरिजिनल मैट्रिक्स में बी की पोजीशन पर क्या था एंड ई की पोजीशन पर क्या था, ये चूज कर सकते हो. रिड्यूस मैट्रिक्स में जो मिनिमाइजेशन का केस है वहां पर सपोज आई एम फिक्सिंग दिस, ऑब्वियसली दिस आई हैव टू डिस्कार्ड. am I right? तो ये जो एलोकेशंस है ना आप डायगोनल में कर सकते हो. सेम रो या सेम कॉलम में कोई एलोकेशन नहीं आएगा. अगर यहाँ पर एलोकेशन है तो रो 1 एंड सेकंड कॉलम में कोई दूसरा एलोकेशन नहीं होगा. मींस आई हैव टू स्ट्राइक आउट दिस वन. सेकंड चॉइस हमारे पास, अगर मैं ये सेलेक्ट करती हूँ तो ये भी सिलेक्शन कर सकती हूँ मैं, कोई भी इस रो में या कॉलम में नहीं आ रहा है. सो इफ आई एम गोइंग टू सेलेक्ट दिस वन, ऑब्वियसली दिस आई हैव टू डिस्कार्ड. अगर इस कॉलम में कुछ है तो वो भी डिस्कार्ड करना पड़ेगा. सो सी हियर आई एम डूइंग द रैंडम चॉइस. मल्टीपल ऑप्शंस आर पॉसिबल आफ्टर दिस केस. किसी भी रो में या किसी भी कॉलम में हमें सिंगल जीरो की एंट्री नहीं मिल रही है. Multiple zero entries are there and hence we are having tie up for the selection and random choices allowed. अब मुझे डायगोनल में चेक करना है. सो हमारा फर्स्ट कॉलम गया, फर्स्ट रो गई, सेकंड कॉलम गया एंड सेकंड रो भी गई है. ठीक है. अब यहाँ पर हमारे पास चॉइस बचता है S3 के लिए सिर्फ इतना, दूसरा कोई है नहीं. लेकिन इस रो में कुछ जीरो नहीं है लेकिन कॉलम में जीरो है, उसे मुझे स्ट्राइक आउट करना पड़ेगा. करेक्ट. कम टू नेक्स्ट S4. अगर मैंने इसे या इसे किसी को सेलेक्ट किया तो अदर एंट्री हमारी डिस्कार्ड होगी एंड आई विल लेफ्ट आउट दिस वन. तो हम यहाँ पर ये लिख सकते हैं विथ रैंडम चॉइस एलोकेशन इज एज फॉलोज. ठीक है. क्या एलोकेशन फॉलो हो चुके हैं? S1 is allocated to B. ठीक है. Then S2 is allocated to A. Then S3 is allocated to E. S4 is allocated to C and S5 is allocated to D. तो ये है हमारा allocation. Noted? Is that method is clear? इस प्रॉब्लम में बहुत सारे tie up हमें मिले हैं and the cases we have discussed. So everywhere we are having random choice and because of the random choice Hungarian method may or may not give you the optimal solution. Means क्या? जैसे मैंने ये allocation किया है ना, now S1 के अक्रॉस B के लिए आप cost matrix से value choose कर सकते हो. You just remember this part, we'll get back to that matrix. यहाँ पर आते हैं. हमारा choice क्या है? S1 के लिए B. S1 के लिए B मीन्स ये वाला पार्ट, सो 38 प्लस S2 के लिए A, S2 के लिए A, सो 40. देन S3 के लिए E प्लस 37, S4 के लिए C, सो इट्स 41 एंड S5 के लिए D, इट्स 39. सो ये सम आपकी जो भी आएगी दैट विल बी द मैक्सिमम सेल after the allocation of salesman to the particular district. Now, these values may change. अगर आप यहाँ पर allocation change करते हो, मैं different color के साथ शो करती हूँ. So अगर मैंने ये choice किया होता and ये discard किया होता, in that case मुझे ये भी discard करना पड़ता, ये भी discard करना पड़ता, right? And I have the only choice to left out. मुझे ये select करना पड़ता. In that case ये discard हो जाता, right? So such multiple choices are available with us. Out of all multiple choices, we can randomly choose the allocation and we can write down at least one allocation as our solution. At least one. Got my point, everyone?
Yes, ma'am.
Okay. So this is a little lengthy problem, but in fact much of the lengthy problem I may not give you in the examination because यहाँ पर हमने कितने iterations किए हैं. Just let me show you. This is your original matrix. उसे हमने row minimization में convert किया. First of all, row reduction, column reduction, random choice. यहाँ पर first iteration लिया हमने. This is second iteration and third iteration पर हमें allocation मिले. Correct? So at least 5 times that cost matrix we have to rewrite down. with obviously the specification of each of the step. So ये है हमारा maximization का pattern. I have solved few of the problems of maximization of the assignment, maximize the profit of assignment problem, and few of the problems I have also solved on the preliminary part. So that all solved problem I can share with you. All of these problems are handwritten problems. I have not noted that on journal, but I can share with you for your practice. So you can have your answer and cross tally with mine. Our next category is this one, unbalanced assignment problem. So it's also not a big issue to solve unbalanced assignment problem. If number of rows and number of columns are not equal, I have to add either a column or a row to balance our assignment problem, and afterwards in regular way apply that Hungarian method. So problem is not at all very difficult. Okay, you can check out one problem under that. I hope we have given here any one of problem up like that. Okay, we don't have any problem of unbalanced type. Just give you here. Let me just. It's a A1 or A, B, C, D. I'll just write down.
If we add dummy column or rows with zeros, all zeros.
Sorry. Come again. It was not audible. Hello.
Okay, no, I got my answer.
Huh? You got that right.
I got my answer.
Okay. Yes.
Exactly, something very silly.
So here is one unbalanced problem. So यहाँ पर है x y z, and now x y z we have to allocate to a b c d, but it's unbalanced because यहाँ पर number of jobs and number of workers है नहीं है. So I'll just add one more thing here. It's key. Suppose this allocation only you have been given. It's 18, 24, 28, and D 32. For Y, it's 8, 13, 17, and this is 19. Then for C, it's 10, 15, 19, and 20. So as number of allocation, number of jobs and number of workers are not equal, I can add one row over here and I can put up all the zero entries. So while doing allocation, it will help you a lot. Now once we will be adding this either row or column with all zeros entries. Our task is very simple. So अगर आप रो ऐड कर रहे हो तो कॉलम वाइज रिडक्शन करने की जरूरत नहीं है. अगर आप कॉलम ऐड कर रहे हो तो रो वाइज रिडक्शन करने की जरूरत नहीं है. See, row wise this is your list number and you can subtract that from rest of. यहाँ पर ये आपका list number है और यहाँ पर ये list number है. So you can subtract all of these numbers from each of the row. But column wise reduction के लिए first column is already having this 0. No need to reduce it. These further columns are also having 0, so no need to reduce it column wise. So once you have this matrix, you can easily apply Hungarian method. Right? Convert that first of all in terms of the row reduced and column reduced matrix, and then apply the row as well as column scanning. Problem is pretty easy. I hope you will be able to solve this. Shall I go for it? Hello?
Yes, ma'am. The same way we need to go for the.
Yes, in exactly similar way. Here also I will get two types of solutions, two types of allocations, I must say. So I can write down the answer over here, you just cross check. So one type of allocation I'll get in this way. A is allocated to X, then B is allocated to Y, and C is allocated to Z, and allocation of D and T is immaterial. हमने allocate किया या नहीं भी किया, that cost is adding to 0. So allocation सिर्फ ये होगा. Second allocation I can write down in this way. X is allocated to A, then Y is allocated to B, and C is allocated to Y is allocated to C over here, and C is allocated to B. Z is allocated to C. Sorry, B. So this is our answer. We can cross check this answer once. After applying the Hungarian method in exactly similar way how we did earlier. I hope you will be able to do this. What difficulty I think you may have while solving the problem is the selection of tie values. Else it's not very difficult to apply the Hungarian method to any assignment problem. So it's entirely based on the choice, your choice for the tie values. I hope it's clear, and we'll move to the next part. This is the last part of our assignment problem. Restrictions assignment.
Ma'am, you are recording this session?
Yes, I have started the recording. So I'll just go to this part of the assignment problem. Restrictions whatever we are having on the assignment. For example, a particular job may not be given to a particular worker. So if in such a restriction we are having, in that case, we assign a big value, comparatively very large or big value to that restricted part. So we are going to use that very large value as infinity instead of m. We may get confused with that m. So all the way your problem will be of this type. So restrictions कहाँ पर है? यहाँ पर restrictions है. What is the meaning of that? That means M2 I cannot assign to C, and M3 I cannot assign to A. Apart from that, M2 can be assigned to A, B, D, E, and M3 can be assigned to B, C, D, E. Got my point? And to avoid allocations of M2 to C and M3 to A, what we are going to do is we are allocating this value as infinity. Means obviously whatever number you are going to subtract from infinity will remain infinity, and obviously the allocation will not be done. क्योंकि कोई भी वैल्यू अब इस infinity से अगर subtract कर रहे हो तो वो least हो ही नहीं सकती, zero आ ही नहीं सकती. So that approach we can follow if we are having any restricted assignment problem. Is that clear? Shall I proceed?
Yes, ma'am.
Okay. Now, this problem is not only the restricted assignment problem but also unbalanced assignment problem, because we are having machines 4 only and locations are 5. So I will add machine M5 over here with all 0 allocations. And with this I can solve my assignment problem to find out optimal assignment schedule. Okay, so let us try to solve this problem and we can conclude this assignment problem with this problem only. So one more problem is given over here. We are not going to discuss the traveling salesman problem over here. It has a little different implication, so I'll exclude that. But only assignment problem, unbalanced, balanced, then maximization of maximize the profit in assignment problem, and restrictions with assignment problem. That's the categories we are going to deal with. Okay. Yes. So let us get back to this problem. I'll just check out whether this problem is noted with me or yes. So as I can write down the values immediately on journal. Yes, second problem. So I'm having locations A, B, C, D and E and machine 1, 2, 3, 4 and 5. So problem is unbalanced, so I'm adding that fifth machine over there. The values are 9, 11, 15, 10, 11, okay? Then 12, 9, infinity, this is the restriction, 10, 9, over here this is infinity, 11, 14, 11, 7, this is 14, 8, 12, 7, 8 here, and this is 0, 0, 0, 0, 0. Alright, so I noted the cost matrix over here. I'll just write down this infinity here. So first of all, we have to row reduce it, column reduce it, and then try to go for the allocation. So over here we already added two steps. One, restrictions जहाँ पर है वहाँ पर infinity add किया मैंने, and unbalanced problem था उसे मैंने balance कर दिया. तो two steps we already have done over here. Now next thing is मुझे यहाँ पर row reduce करना है. So least value मैं यहाँ पर least value लिखती हूँ. First row की it's 9, second row की भी 9, third row की 7, fourth row की 7 and fifth row की 0. So fifth row को कुछ subtract करने की जरूरत नहीं है. It's already 0. So मैं फर्स्ट रो को सिंप्लीफाई करती हूँ. यहाँ पर 0 आएगा, दिस इज 2, यहाँ पर आएगा 9 and 6 15, यहाँ पर आएगा 1, दिस इज, यहाँ पर 3, दिस इज 0, यहाँ पर आ जाएगा 1 एंड यहाँ पर 0 वंस अगेन. इन्फिनिटी माइनस 9 क्या होगा? इट विल रिमेन इन्फिनिटी, तो मैंने यहाँ पर कुछ चेंज नहीं किया, ठीक है. देन 7 is the least value. Infinity minus 7 will remain infinity here. 11 minus 7 it's 4. 14 minus 7 it's 7. 11 minus 7 4 here once again, and this is 0. Next row, least value is 7, so यहाँ पर बचेगा 7. This is 1. This is 5. 0 and this is 1, and this row will be as it is. Now let us check column wise. अब column wise हमें column reduce करने की जरूरत नहीं है, क्योंकि हर एक column में ये इस 0 की एंट्री है. तो this is the least value. तो हमें यहाँ पर reduce matrix ऐसे मिल रहा है. I'll just rewrite down that once again. This is A, B, C, D, E, and यहाँ पर machine है 1, 2, 3. This is 4 and 5. So 0, 2, 6, 1, 2. मैं यहाँ पर थोड़े से steps कट शॉर्ट कर रही हूँ. I hope you are understanding. Wherever you will feel like that this is not very much clear, please ask me to repeat it. And this is 0, 0, 0, 0. Now this यहाँ पर हमने 4 स्टेप पुट अप की है. रेस्ट्रिक्शंस जहाँ पर है हमने वहां पर इंफिनिटी पुट अप किया है, राइट. देन रो रिड्यूस किया है, अनबैलेंस्ड टू बैलेंस्ड कन्वर्ट किया है, ठीक है. एंड कॉलम रिड्यूस किया नहीं है, बट ये कॉलम रिड्यूस है ऑलरेडी. सो दिस 4 स्टेप्स आर ओवर. अब यहाँ पर हम स्टेप फॉलो कर रहे हैं रो एंड कॉलम स्कैनिंग की, ठीक है. सो लेट अस स्कैन दैट. I'll take a different color here. So row wise this is 0. So हमें 0 को allocate करना है. पहला 0 हमें मिल गया, सिंगल 0 है, so I can strike out this column. सेकंड रो में यहाँ पर 2 zeros है, I cannot allocate. थर्ड रो में एक 0 है, I'll just allocate that here. तो यहाँ से कॉलम की सारी वैल्यूज हमारी हट जाएगी, सो ये 1 भी हट जाएगा, ठीक है. देन नेक्स्ट रो में एक 0 बचता है, सो मैं इसे allocate कर देती हूँ एंड I'll strike out this column once again. फिफ्थ रो में 2 0 की वैल्यूज है, I cannot allocate. Now let us go column wise. First column is already discarded. सेकंड कॉलम में 2 zeros की एंट्रीज है, I cannot allocate. थर्ड कॉलम में यहाँ पर एक ही 0 की एंट्री है, I can allocate, but now I have to strike out the row. तो ये 0 जाएगा, ठीक है. And now I have left out still single zero, so I can again go back to the row as well as column scanning. So मैं ये कंप्लीट करती हूँ. C वाले में allocate कर दिया हमने, D वाला and E वाला ऑलरेडी स्ट्राइक आउट है तो नहीं करेंगे. कम टू रो वाइज वंस अगेन. फर्स्ट रो में कुछ बचा नहीं है. सेकंड रो यहाँ पर जीरो है, सिंगल जीरो है, तो मैं इसे अलोकेट कर देती हूँ. एंड मैं रो वाइज अलोकेट कर रही हूँ तो मुझे कॉलम को स्ट्राइक आउट करना है. ठीक है. अब यहाँ पर देखो कितने नंबर ऑफ जीरो हमने अलोकेट कर दिए हैं. नंबर ऑफ एलोकेटेड जीरोस कितने हैं? 5. एंड व्हाट इज नंबर ऑफ रोज हियर? वो भी कितनी है? 5. सो वी रीच टू ऑप्टिमलिटी. And I can write down my allocation here. So मैं allocation लिख सकती हूँ. Machine 1, machine 2, machine 3, this is machine 4 and this is machine 5. Machine 1 का allocation किसके साथ हुआ है? Location A के साथ, right? Machine 2 का B के साथ, machine C का E के साथ, मशीन 4 का D के साथ एंड मशीन 5 का C के साथ. जबकि ये मायने नहीं रखता क्योंकि ये आपको जीरो कंट्रीब्यूशन दे रहा है कॉस्ट मैट्रिक्स में. गॉट माय पॉइंट? सो एलोकेशन है M1 का A के साथ, M2 का B के साथ, M3 का E के साथ, M4 का D के साथ. नाउ हमें ये ऑब्जर्व करना है कि रेस्ट्रिक्शन सेटिस्फाई हुए या नहीं हुए. लेट्स चेक आउट. M2 को C एलोकेट बिल्कुल नहीं होना चाहिए था, नहीं हुआ है M2 को C एलोकेट, करेक्ट. M3 को A एलोकेट नहीं होना चाहिए था, ये भी नहीं हुआ है. सो आवर allocations are up to the mark following all the restrictions and following the unbalanced assignment problem also. Got it? So many of the times it's needed to calculate the cost also. So minimum cost is क्या होगी? M1 एंड A के अक्रॉस जो कॉस्ट होगी, सो इट्स 9 प्लस M2 एंड B के अक्रॉस जो होगी वो इट्स 9 प्लस M3 allocated to E 7 and M4 allocated to D 7. $32. So that's our value, minimum value. Got it? I hope this part is clear to everyone now. Shall I repeat anything? We are having one more problem over here. 5 workers of similar type where restrictions we are having. So including that restrictions we can solve the problem. Now it is balanced one. Next problem.
Okay.
Okay. Any further doubt, anyone?
No, no. We can go.
So with this I am completing this assignment problem as well as unit 2. We are still left out to complete unit 3 and unit 4. Unit 3 is of game theory and unit 4 is of network analysis. If possible, if unit 3 don't have any further contribution to or further linkage to unit 4, we can take 4th unit first and the 3rd unit later on. I'll just check it out once and I'll take accordingly. Alright. One more question initially I asked to Avinash, that if it is not possible for you to attend this particular session from 7 to 9 because it will left hardly 3 weeks to conclude your entire syllabus of this semester. That means only 6 lectures or 6 hours are left out, and it's not possible to complete the rest of 2 units within that 6 hours. So what will I do? I will record the videos of any one of the unit, and any one unit I'll conduct in online mode. Will it be okay?
Yeah.
Yes, ma'am, it's okay.
Yes, ma'am.
Okay, so simultaneously I can prepare the videos, I can post it, and simultaneously I can start the next unit as well. Apart from this, question bank, video lectures and PPTs I will upload on Classroom so that you can access it by any time for your preparation.
Ma'am, can you post this today and last lecture assignment? From
Yes, I guess last lecture I posted already, isn't it?
No, I think.
Okay, I'll check it and I'll upload. Don't worry.
Okay.
Any other queries from your side? So,
On that.
okay, so from Monday onwards, I will start posting the videos of one unit, and on coming Thursday, we will be starting with the another unit. All right?
Okay.
Okay. Let's stop over here then, and we'll meet on next Thursday.
Yes, ma'am. Okay.
Thank you.
No, actually half are still remaining, but it will not be possible to start with any one of the unit. Introduction will require 1 hour at least. So we'll stop here. We'll freshly start next Thursday, next unit.
Okay.
Okay. Yes. Thank you, everyone.
Good night.
Thank you.
Yes.
Thank you.